Yeah, we are going to continue the problem now. So the problem is, one second. So this is what the problem is, and now we are considering the friction as on the surface as mu s. So on the surface the friction is mu s and mu k, and so what is the minimum force? Find minimum force to move the blocks, and on the next question is reaction force between the blocks. So reaction force between the blocks. So first let's see minimum force required. Okay, first let's see minimum force required. When the minimum force required, we need to draw the free body diagram. Free body diagram, two objects are there, m1 and m2. So there is a applied force F and there is a friction. Before writing the friction, first let's go through the normal, and this is a, let's draw the normal. Normal is vertically upwards. On this I will say n1, on this say the normal will be n2, and the downward force is m1g and the other force is m2g, and friction on this block it will be in the backward direction. I will change the color now, wait a minute. Friction will be in this direction. So because it's a static it's a body, minimum force, it's in a verge condition, so mu s into n1. So on this the friction will be in the backward direction, mu s into n2. So let's write the force equations now, total. Okay, writing the force equations as of now, positive and positive. Wait a minute, I'm creating some pages. Okay, few pages. Now right side force is equal to left side force. So what is the right side force? Applied force F in the right direction plus F. So acceleration becomes 0, obvious. Right side force must be equal to left side force, and what are the left side forces? Mu s n1 and mu s n2. Mu s n1 plus mu s n2. I can write this one as mu s as a common factor n1 plus n2. This is the applied force. Okay, and to get n1 is equal to m1 into g, n2 is equal to m2 into g. So the applied force F is equal to mu s into m1 plus m2 into g. This is the minimum force required to move the block. Okay, now in this case reactive force in between. So reactive force also is important. Now let's do acceleration is equal to 0. Okay, reactive force between the blocks. Reactive force. So reaction force or reactive force, whatever it may be. So to do this, we should draw individual bodies free body diagram. So now see this body, the right side towards the right, F is a force, the mass is m1, and the friction on this block in this direction. If you see this diagram, on this block mu s into n1. So it is mu s into n1, and again intermediate situation. This is the contact surface. On this contact surface, on the m2 tries to oppose the m1 and m1 tries to push m2. So on the m1 the reactive force in the backward direction, m2 will be in this direction. I am just keeping it as r. If you take overall body, r gets cancelled, that's why we not include in this case. Okay, so the r will be in the left side action, r, and the normal n1 is in the upward direction and m1g is in the downward direction, and acceleration is equal to how much? As of now, 0. Acceleration is 0. So if you write the equation for this, so right side force must be equal to left side force. Right side force is plus F, and the left side forces are R plus mu s into n1. Okay, so what is n1? N1, this is the first expression. N1 is equal to upward force is equal to downward force, m1g, equation 2. So F is equal to R plus mu s into m1 into g. R is equal to F minus, so this is a minimum force as our discussion is. So so F is equal to F minimum is equal to, okay, I'll write as it is, F minus mu s m1 into g. So if we substitute this, what is the minimum value of force we got? Force we got mu s into m1 plus m2 into g minus mu s into m1g, and m1 mu s m1g gets cancelled, mu s into m2g. This is one way of doing. We'll do in another way also. So we took the first block, m1 block we considered. So now I am considering the next block, m2 block. If we take the free body diagram of it, the friction is acting in the backward direction. This friction is equal to mu s into n2. Okay, and the reactive force is acting in the right direction. This is R, and the normal in the upward direction, and m2g is in the downward direction. Okay, so now let's solve this equation. Right side force, so right side force acceleration is equal to 0, so right side force must be equal to left side force. R is equal to left side force F. F is equal to R. F is nothing but mu s into n is nothing but m2g. Which one is easy? What do you feel? Based on that